Evaluate integral 0 to 5 x square plus 1 using definite integrals as limit of sums. How do we do that? So for that, we'll recall the formula first. Integral a to b fx dx is equal to what? So the version that I would like you to remember is this, that limit n tends to infinity b minus a upon n is what I have. In the brackets, what do we have? F of a plus f of a plus h plus dot 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 f of a plus n minus 1 h. This is what we are interested in. Here h is equal to b minus a upon n. Okay, this b minus a upon n is also nothing but h, right? So you can replace that also with h, but then this limit n tends to infinity will not make much of sense. So instead of n tends to infinity, what you can simply write it as h tends to 0, right? That's what you can write it as. So h is equal to b minus a upon n, that's one of the things, and we have this integral over here. Once you have this integral, can you identify that when I compare I equals integral 0 to 5 x plus 1 dx, by that expression, what do I see? I see that a equals 0, b equals 5. I see that a equals 0, b equals 5. I also see that f of x is equal to x plus 1. And what else do I know? I know that h is equal to b minus a upon n, which is 5 minus 0 upon n, which is 5 upon n. So h here is 5 upon n. This is what you have. Therefore, I is equal to, as per definite as limit of a sum, this is equal to limit n tends to infinity b minus a upon n, which is this. B minus a upon n is 5 upon n first of all. In the bracket you have f of a. Now f of a is this. A is simply 0, f of 0 is 0 plus 1. That's what you'll get. So let me write f of 0 first. F of 0 plus h becomes f of h, f of 2h plus dot 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 plus f of n minus 1 times h is what I'll get. This is the first bracket, right? That's the first expression. This is what I would like you to follow. Limit n tends to infinity. This is 5 upon n, which is pretty simple. In the brackets you have f of 0. F of 0 can now be replaced by 1. F of h is nothing but h plus 1. 2h is 2h plus 1 plus dot dot dot. This is n minus 1 h plus 1 in the bracket, and close the bracket after that. This is what you get. Now simplify this expression further. Limit n tends to infinity will remain as it is. 5 over n will remain as it is. And what is this? In this square bracket, you have total 1, 2, 3 and dot 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 up till n terms. So let's pick up these 1, 1, 1, 1, 1. And we'll also pick up h, 2h, n minus 1h. So we'll have h plus 2h plus dot 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 plus n minus 1 h over here. This is one of the expressions. Plus, you have 1, 1, 1. How many times? 1 plus 1 plus 1 plus dot dot dot. This will come how many times? 1, 2, 3 up till n minus 1. Starting from 0 to n minus 1, you'll have n terms over here. So these are n terms. This is n times. You get this one. And now simplifying that expression will not be difficult at all. Let me write the further steps over here. Therefore, I becomes equal to what? Limit n tends to infinity. 5 upon n is what I have. And here I can take out a h common. What is remaining is 1 plus 2 plus 3 plus dot 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 up till n minus 1, which is sum of the first n minus 1 natural numbers. H is okay. Sum of first n minus 1 natural numbers, that will be n minus 1 times n minus 1 plus 1, which is n by 2 plus this overall is sum of this. 1, 1, 1, n times is simply n over here. Okay, and now I can replace this h by 5 by n over here. This becomes limit n tends to infinity 5 by n times 5 by n in the bracket. This 5 by n will go over here. 25 upon n square times n minus 1 times n by 2 plus 5 by n times n is what I'll have over here. And this thing further be simplified for substituting this n tends to infinity, that applying the limit. This will be 25 by 2, n square and n will get cancelled. What will remain is n minus 1 upon n, which is 1 minus 1 upon n plus 5 over here. This is what will remain. Now, so putting n tends to infinity will make this 0, so this becomes 25 by 2 plus 2. So this overall value is 25 by 2 plus 5, which is 35 by 2, and that is my required answer for this question, as you can see over here. That's the final answer for this complete question.